Hello Year 12 and welcome to Purple Mountain Maths. Today we're doing the 2025 HSC paper for Math Standard 2. This is part 7, question 35, 36, 37. Question 35. The triangle PTA is shown. The length of PA is 75 metres and the length of PT is 51 metres. The angle of depression from T to A is 36 degrees and the angle PTA is obtuse. Find the length of TA. Give your answer correct to 2 decimal places. Pause here to try yourself. All right, let's use the information we've been given. The angle of depression from T to A is 36. So they're telling us that if I extend this parallel to the ground and I go down like that, that's 36 degrees. If that's 36 degrees, then so is the angle at A, because alternate angles on parallel lines are equal, and I can also figure out what part of the angle is of T. I could use my calculator, or I could just know that 90 less 36 is 54. So this part is 54, but that's not all of it. Let's have another angle here, which I might call beta. And I'm going to need to figure out what that is. And I know that beta plus 54 is more than 90 because obtuse means between 90 and 180. Okay, we've done enough now to set up sine rule. The angle at T is what we're looking for, so I'm going to make that in the top left-hand corner of my equation. So sine T over 75 is in the same ratio as sine 36 over 51. So sine of T equals 75 sine 36 on 51. I can evaluate all of that. 75 sine 36 over 51. I get 0.864. Right, so T is the inverse sine of all that. So if I inverse sine my answer, shift sine answer, I get that T is 59.81 degrees. Now that's the right answer if it had been acute, but we know that it's not. And my calculator will only initially give me the acute answer. T equals 59. You could write it using degrees, minutes, seconds or not, it doesn't matter. If obtuse, T is 180 minus that, and we know that that's the case. So we need 180 minus that answer. So it is in fact 180.187 or 180 degrees 11 minutes. Sorry, 120 degrees 11 minutes. Okay, so now I've got my angle at T. That's the first step. So I know that this is 120 degrees and 11 minutes. I know that the other angle was 36, so I can work out the remaining angle at P. So that plus 36 gets me to that, and 180 minus that answer reveals the angle at P. So the angle at P must be 23 degrees and 48 minutes. So P equals 40 23 degrees 48 minutes. Right, so we've got all three angles. So we know that this is 23 degrees and approximately 49 minutes. I can now go ahead and use cos rule because I've set it up so that I know one of the sides, I know the other side, and I know the included angle, and I'm looking for the length of TA. So this is a classic setup requiring me to use the cos rule. Okay, so let's go ahead and use cos rule. Straight off the reference sheet, you know c squared equals a squared plus b squared less 2ab cos c. When you've taken care to make c the length that you're looking for, and you do know the angle opposite c. So in this case, we've got 51 squared plus 75 squared less 2 by 51 by 75 times cos of the angle at P, which I know. So I can put all of that in my calculator. So because that's already just sitting. Okay, so reuse that angle answer. When you put all of that in your calculator, you'll get c squared equals 1227.266 and so on. We don't want to know what c squared is. We want to know what c is. So c is the square root of that. And I'll get c is approximately 35. Now look, it will be quite sensitive to rounding. And the reason it's sensitive to rounding is because you've been using angles. Try to take care to use the exact angle all the way through, but to 2 decimal places, I get 35.03. And that's the answer in metres. Question 36. The graph shows the salvage value of a car over 5 years. The salvage values are based on the declining balance method. By what amount will the car's value depreciate during the 10th year? Pause here to try yourself. All right, so what can I see that's helpful? I can see that at t equals 0, it has a value of 55,000. So at t equals 0, the salvage value equals 55,000, which implies that that's the initial value. I can also see that at t equals 1, goes straight through that point there of 44,000, so S equals 44,000. So that tells me, I'm just going to use straight off the reference sheet the formula that the salvage value is the initial value 1 minus r to the power of n. So I know 44,000 equals the initial value 1 minus r to the power of n. So that's revealing to me that I can work out 1 minus r. It must be 44,000 divided by 55,000. So cancel. So that's 4/5. If 1 minus r is 4/5, then r must itself be 1/5. So r equals 1/5 or 0.2. So now I'm ready to use the formula. I've got the structure of my formula. I'm just going to write it that S10 equals the initial value 1 minus r to the 10. And they're actually interested in the 10th year, so from its value at the end of 9 years to the value at the end of 10 years. So I'm also going to be needing what's going on after 9 years. So let's just put all my values in. 55,000, 1 minus r, but I know what r is. R is 0.2. 1 minus 0.2 to the 10. And I can put all of that in my calculator, and I get 5905.58. And S9 is 55,000, 1 minus 0.2 to the 9. Putting that in my calculator, I get 7381.98. So I'm interested in the difference between those two values. So the difference in value equals 1, the bigger one, less the smaller one. And I get 147640. And that reduction in value is by definition how much it depreciated by. So the depreciation is that as a value. And that's my answer. Question 37. The diagram shows a part consisting of two equilateral triangles. The shaded triangle is a grass section. All measurements are in metres. How long will it take to mow the grass section if it takes 5 minutes to mow 20 square metres? Give your answer to the nearest minute. Pause here to try it yourself. Okay, so equilateral triangles means that everywhere I see an angle at 60 degrees. That's 60, that's 60, and that's 60 in the bigger equilateral triangle, and that's 60, that's 60, and that's 60 in the smaller equilateral triangle. In order to work out area, I'm going to need to use area equals a half AB sine C. And so the sides that I need to find, I'll call this X, X, X. I'm looking for the size of that smaller triangle. All right, but if I just focus on a triangle like this one at the bottom, I actually can see in that triangle, I do know one side is 3, one side is 9, and the included angle is 60. So I can use a cos rule. So straight off the reference sheet, c squared equals a squared plus b squared minus 2ab cos c. So in this case, x squared equals 3 squared plus 9 squared less 2 by 3 by 9 cos of 60. I can put all of that in my calculator. 3 squared plus 9 squared less 2 by 3 by 9 by cos 60. Close bracket. Okay, I get 63. That's what x squared is. I don't want to know what x squared is. I want to know what x is. So x is root 63. I'm just going to leave that in that format. I want to keep it as exact as I can. So now I'm in a position to use the area formula in the smaller triangle. So area equals a half of root 63 times root 63 times sine of 60. So I can do that. So I've got a half of root 63 times root 63 times sine of 60. Okay, I got 27.2798. 27.2798. That's in meters squared. Just take care to give them actually what they want. They don't want to know that number. They want to know how long does it take to mow. Okay, so we need to set up a question involving ratios now. So we know that every 5 minutes relates to 20 square meters. So the question is, how long will it take for 27.2798 meters? So the t I'm looking for must be 5 times 27.2798 over 20. I'll do that in my calculator. So I already have that number there, times 5 divided by 20. I get 6.8199. And they want it to the nearest minute, so that's approximately 7 minutes. And that's my answer.